Again, welcome to Java programming language. In these lectures, we're going to discuss about how to, again, develop a software. That's a software development process, the steps that we're going to follow to develop a software. Again, this is Unit 2, lecture number 3. So our main objective is we are going to describe software development process and also apply it to develop a low payment program. Also, we are going to write a program that converts a large amount of money into smaller units. And also how to avoid common errors and also pitfalls in elementary programming. So we start with the software development process. And this, again, in software engineering course, we have so many techniques in developing a software, the process in developing a software. Example can be extreme programming, Scrum. Again, we have so many types. And the most classical method is what we call the waterfall model. So the software development process here follow the concept of, again, waterfall model. That's in software engineering course. So normally when we're going to develop a software or we are going to write a programming code, there must be a problem that we are trying to solve with computer programming code. And there are some problems that there are some real world problems that we can't use a computer to solve it. Or if we use a computer to solve it, it will not be too much beneficial than actually maybe trying to solve it manually. So that's the main reason why before we develop a software, we must understand our problem. And also we have to understand what will be our input to the program and what will be our output. Now, the process of converting an input to an output, we need to write an algorithm or design an algorithm. So in software development process, we start with the requirement specification. The requirement specification is where we have to analyze our problem to know what are the inputs, what are the outputs, what are the functions of the program. We have two types of tasks or a function. We have function requirement, or the function of a program will be the tasks that the program will perform. We also have a non-function requirement, which will be based on the quality of the program. For example, in this software, it says security more important than the speed, or is the user friendliness more important than maintainability? So we are going to consider all this. The non-functional requirement will talk about the quality of the program, maybe the speed, user friendliness, etc. And then the functional requirement is what the program will do. So that's our first step, requirement specification. We analyze the problem, what will be our input, what will be our output, what are the functions of the program. Then we move to the system analysis. So again, we start with the requirement specification. Here we said this is a formal process that seeks to understand the problem and document in detail what the software system needs to do. So this phase involves close interaction with users and designers. Normally the requirements, as I mentioned earlier, functional and non-functional requirement, the specification of the program. Normally we can get this information from the users of the system. If it's a business organization, maybe they solve this problem manually. So they will tell us how they solve it manually. Then we apply it to the computer system. Or they have an old computer system. In this case, we are trying to come up with a new version, more features, quality. So we still need some information from the users and also the management of the organization. So the next step, again, we're going to move to the system analysis. So for example, most of the example in our lectures, the requirements are stated clearly. But in the real world, however, problems are not well defined. So again, in this our course, Java programming language, most of the program we are going to write would be very simple, not too complex. But in a real world complex system, again, we need to take requirement specification very serious and try to come up with a possible specification for the requirement, both functional and non-functional. So next we move to the system analysis. So here we try to seek to analyze the business process in terms of data flow and also identify the system's input and output. So in this section, we may try to understand the business rule, the operation procedures in the business organization. Then we analyze it. Then next we move to our design phase. So part of analysis will entail the modeling the system behavior. So the model is intended to capture the essential element of the system and also to define the services to the system. Then in the system design, the process of designing the system components. This is where we are going to design the algorithms. We have, again, the system design phase, we may have different tools to design our algorithm. For example, we can use the diagram such as the unified modeling language. We can design our classes. We may design our use case diagram, etc. The uniform modeling language is a very good tool for designing object-oriented systems using the object-oriented concept. So this phase involves the use of many levels of abstraction to decompose the problem into manageable components, identify the classes, interfaces, also establish relationship among the classes and interfaces. So when we design our system finish, the next step, we are going to do our implementation. So we know the program always go with the input, processing, and also the output. So the essence of system analysis and design is the input, processing, and the output. Next step, again, we are going to do the implementation. This is the step that, or the phase that we are going to use our Java programming tool. We are going to write the code based on the design that we have. So the process of translating the system design into programs. We need to separate the programs written for each component and put to work together. So normally in object-oriented programming, we may identify, let's say 10 classes. So we are going to write the code for each of the classes, then later we integrate them or put them together. So this phase requires the use of programming language like Java. The implementation involves coding, testing, and debugging. So the next phase will be our testing. There are so many testing methods. For example, if we implement the system and we have different units, we can do what we call the unit testing. Test each unit if there's no error. Now, if there's no error, we combine the system together, we integrate the system, then we can do what we call the integrating testing. We also have alpha testing where we test the system at the company organization, etc. So here we ensure that the code meets the requirement specification and without bugs. Our main goal of testing again is to without any specific bugs or errors. So an independent team of software engineers not involved in the design implementation of the project usually conduct such testing. And one of the entry level in software engineering is a software tester. So we have special people and software testers who are going to test the system. So after we test and everything went successful, the next step is the deployment. And so here we are going to implement the system in the business organization and deploy it. So deployment makes the project available for use. So for Java program, this means installing it on a desktop or on a web server or on the web. Now, in the process of using it for some time, we may need a maintenance. So maintenance is concerned with changing and improving the product. Maybe we have to write some code to update the software, etc. So a software product must continue to perform and improve in a changing environment. So this requires periodic upgrade of the product to fix newly discovered bugs and also incorporate changes. So let's see an example. We are going to apply what we learn now in a program to compute a loan payment. So we know that our first thing we have to do our requirement specification. So the requirement specification is for us to understand what we are going to do, the program. So in this program, we are going to write a program that can compute a loan payment of clients or customers. So this program lets a user enter the interest rate. So that's one of our input, the number of users, the number of years, and also the loan amount. So those will be our input. Again, program lets the user enter the interest rate, the number of years, and the loan amount, and compute the monthly payment and total payment. And that will be our output. So we came with the idea that this is the formula we are going to use, which is monthly payment equal to the loan amount times the monthly interest rate divided by 1 minus 1 over 1 plus monthly interest rate raised to the power of the number of years times 12. That is the number of years we have to pay the loan times 12, which will make it monthly. So this information, we will get this information during the requirement specification and also the analysis, the system analysis phase, and also the design. So the design is coming up with the formula, etc. Then after the design, then we move to the coding. So here we have a Java program. We say the program will ask the user to enter some 3 values, the interest rate, the amount, etc. So this means we need a scanner class. As we mentioned in our previous code, we use the scanner class to create our input object. So here we again import the scanner class alone from the java.util package. Then as usual, we have our main class, which will be the name of the file also. So our main class name is compute loan. So the file name will be computeloan.java. Then this is a very simple program. We have only one main method. So that's our method. So we know always, as we said, we saw it in a software development process, always input, process, and output. So we need to get our input. In order to get our input, we need our input object for the keyboard. So we create an input object using the scanner class with the argument of system.in. System.in here tells us that we are going to use the keyboard. So after we create the input object, which is called input, we are going to use it now to get our input from the user. So next we have instruction here. We are telling the user to enter the yearly interest rate. So for example, if the interest rate is 8.25, you write 8.25, because we declared a variable where we are going to store the yearly interest rate as double. So we declare a variable annual interest rate as double, and we use the input.next double to get a double input from the user. Next, we are going to obtain the monthly interest rate. And that will be the annual interest rate divided by 1200. So again, that will be our monthly interest rate. So annual and monthly, we have 12 months for a year. That's why we are dividing by 1200. and interest rate will be in percent. So we have the annual interest rate. From the annual interest rate, we're able to find the monthly interest rate. So we divide again the annual. We ask the user to enter the annual interest rate. We divide it by 1200, we get the monthly interest rate. Now we are going to ask the user to enter the number of years that it will take to pay the loan. So here we say enter the number of years as integer, for example, 5. So we declare that variable int, number of years. We use the input object. Now the input object, it can be whether you can enter double character, any data type, it will take it. We only need to create the input object once using the scanner class. So next we enter the loan also. And the loan will be double the loan amount. Okay, so we got our information now, our input. Next thing we do is our process. We already know the formula, so we are converting the formula to Java. So the monthly payment will be loan amount times monthly interest rate divided by 1 minus 1, then divided by mat.power. So mat.power is when we have a value raised to a power. So for example, if I have mat.power 2 and 3, it means 2 to the power 3. So mat.power, we have 1 plus monthly interest rate. This will be the base. Then the number of years times 12 will be the exponent. And as we saw it in the formula before, let's go back to the formula. We can see that we have 1 plus monthly interest rate to the power number of years times 12. So that's the mat.power 1 plus monthly interest rate, comma, number of years times 12. So here again, that's why we have the formula here. So again, loan amount times monthly interest rate divided by 1, then minus 1 divided by mat.power 1 plus monthly interest rate, then the number of years times 12. So the formula here is what we know, this formula in mathematics already, so we convert it again to Java. So after that, we now know the monthly payment. Now we are going to multiply the monthly payment by the number of years times 12, because we know every year is 12 months. So if it's 5 years, then we have 60 months. So we multiply 60 months by monthly. Then we know the total payment we have to make. Now we finish with our process. So we have our input process. We display our result, that is the output. So here we say system.out.println, the monthly payment is whatever amount we were able to calculate times 100 divided by 100.0. Then, so that will be the monthly payment. Then the total amount is whatever we have total amount. And here also you can see that we are casting it. We talk about casting, changing it to int, casting. And then we display our result. So let's run this program and see. So here, this is the user enter 5.75, the interest rate, 15 years, number of years, and the loan is 25,000. So here we can see our output here. Enter the year interest rate. The user entered the 5.75. Enter the number of years as an integer. The user entered 15. Then enter the loan amount. The user entered 25,000. So the monthly payment will be 207.6, which is $207.60. Then the total amount is 37,368.45. So again, that's the whole concept here. We get our We start with our scanner object to create the input, get all the input we need. We use the formula to do the processing, then we display our result. So we have another program again. This program will be a monetary units. So this program will allow a user to enter amount in decimal representing dollars. For example, $20.50. So it will be 20.50 and cent. Then we are going to output report listing the monetary equivalent in single dollars, quarters, dime, nickels, and pennies. So if the user enter, let's say $100.50, then we can say, okay, we are going to get 101 unit dollars and 2 quarters. The rest will be 0 dimes, 0 nickels, and 0 pennies also. So let's see this program. Again, first thing we need is our input. So we create our scanner class again. The main class name is compute change, which will be the file name. So in our main method, we create our object again. We name, as we said earlier, the name of the scanner object can be any name. Here we decided to name it input. Then we ask the user enter an amount in double, for example, 1156. So since it's going to be double, we declare variable data type double. Then we use the next double method to extract the input from the user using the keyboard. So after the user entered the amount, we want to convert the whole amount to cents. So we multiply the amount by 100 and we change the decimal to int. So if the user entered 11.56, it will be 1,156 cents, and that will go to the variable remaining amount. Now, since now we know all the amount is in cents, the highest bill will be dollars. So we want to know how many dollars we get. Now, if the user enter 50.80, we multiply by 100, we take the decimal away to get only the cents. So when we get the cents, then we are going to divide by 100 to give it, because 100 cents is $1 to give us how many dollars. So we got 500, let's say 5080. That will give, if you divide by 100, that will give us 50, because it will give us 50.80. So that will give us 50 singles. Then we are going to use the remainder to get the remainder cent. Then we divide by whatever amount again. If it's in quarters, 25, if it's down. But we start with quarters because we start with the highest bill first. The highest bill is $1 bill. The next will be the quarters, then the dime, then the nickel, then the pennies. The remaining after nickels will be pennies remain. So that's what we did here. We multiply by 100 to change everything to cents. Then we divide by 100 because we know 100 cents is $1. So here we have a variable number of $1 that will give us the dollars. Now we want to see the remaining cent. So it's the same variable where we have the remaining amount. We use the modulus 100. Modulus 100 means if I divide the value by 100, what will be the remainder? So the remainder, we are going to put it in the remaining amount variable. Then we are going to divide the remaining amount variable by 25. So we get the number of quarters. And then we do remaining amount modulus 25 to give us the remaining balance after the number of quarters. And that will be in the remaining amount variable. Then next, the number of dimes equal to remaining amount divided by 10. This will give me how many dimes we are going to have. Then we use the remaining amount modulus 10 to get the remaining cents that is left. Then we divide the remaining cent by 5 again to get the number of nickels. The remaining amount modulus 5 will give me the remaining cents. Now the remaining cents will be the last cent. So we assign the remaining cent to the number of pennies. So we finish with our process. Now we know the number of dollars, the number of quarters, the number of dime, the number of nickel, and the remaining pennies or cent. So now we want to print out the output. So here we say your amount, whatever amount we enter, consists of the number of dollars we have, the number of quarters, the number of dimes, the number of nickels, and the number of pennies. If we don't have any, let's say the number of dimes, the calculation, it will automatically give us 0. So that will be the conclusion of this program. Again, here we need to understand what is our input, design our process, how we are going to convert the input to output. That will be the process. Then after that, again, we finish with that step. So there are some common errors and pitfalls when we are writing programs, especially when we start with Java newly. So these are some few errors that we should pay attention to when we are writing our program. For example, we may have a variable, we are using a variable, we didn't declare it. That will give us an error of undeclared. In Java, we always need to declare. Java have a data type, we always need to declare. It's not like Python whereby you don't need to declare the data type. It depends on the value you put in the variable, and the type of value you put in the variable will be the data type of that variable. But in Java, we need to declare our variable before we use it. Also, sometimes we may have integer overflow, which means in Java, as we mentioned earlier in our previous lectures, the data type each have different size. For example, and the long and double, they are all a whole number, but long take larger values than integer. So sometimes if you have a larger value and use integer, we may get something like overflow. Overflow is a very serious problem because the answer you will get will be an error. And also runoff errors, unintended integer division, especially if you divide the value by 0, there's no answer. And also redundant input objects. This means when we create a scanner object once, that's it. As we saw in our previous program, even if I'm getting different data type of an input, I can still use the same scanner object. So don't use that. Actually will even give us error if you create 2 scanner objects in the same program. That's not good. It's an error. So this is an example of the first error. We need to declare our variable first. So here you can see I declare variable double interest rate. We assign 0.05 to it. Then I'm trying to use the variable, but instead of writing interest rate with the capital letter R, I'm using the lowercase r. This will give me an error because again, Java is case sensitive. So upper cases, lower cases must be the same. So this is a common error we can get. We declare variable double interest rate, we assign 0.05. R is capital letter. So when I'm using the interest rate in a formula times 45, I have a lowercase r, and that's a big error. This means interest rate with a lowercase r is a different variable from interest rate with uppercase r. So it's like we didn't declare our variable. The second error we're talking about integer overflow. If I have a very large value and I had only 1 to it, you can see this value here with 1, it takes us back to negative because of the size of the variable data type it can take. Redundant input object. So here you can see that we create a scanner object input, and we ask the user to enter input to v1 variable. Then we create another scanner object input 1 because we are using double to enter, and this is an error. The input object for the scanner class input object, it doesn't matter what data type you use. What matters is the method that you use to extract it. So if it's int, I'll use next int method. If it's double, I'll use next double. So that will be the conclusion of our lectures. Again, in these lectures, we cover the basic concept of software engineering process. And most of the things we went through, or again, we have been through already in the previous lectures. We went through two programming to explain the whole concept. So again, wish everybody the best and thank you for your time.